This video is going to show you how to create an NDVI image. So NDVI means Normalized Difference Vegetation Index. NDVI, or Normalized Difference Vegetation Index, is a formula, and we take two bands, the near infrared and the red, and we apply a formula to it. We take the near infrared, we subtract the red, we divide this by the near infrared plus the red. So when we're working with raster data, we can actually compare two layers against each other. So in this case, we've got the near infrared layer and we've got the red reflectance layer. And each one of these cells has a particular value. So if I zoom all the way in, you can see the boundaries of a cell here. And if I click here, the digital number, or the DN for this particular pixel, is 727. If I toggle that off and I look at the same pixel or the same cell in the near infrared band, then that value is 4,820. Okay, we don't need to worry about what that means. That just means like how much is being reflected. But for each one of these cells, if we've got the two layers, that means that these two rasters are laying right on top of each other, and each pixel lines up with the one that's immediately above it or below it. So we've got a near infrared and we've got a red, and each cell corresponds with one other cell and one other cell only. So when we talk about this formula, which is right here, that means that we're going to take the two cells that overlay with each other, and we're going to take the values of the cells from each image, and we're going to apply this math formula to it. So that's what the software does. So that one value that was 4,000 and something, we'd take 4,000 minus the other value that was from the red pixel, and then we're going to divide that by those two values added to each other. And the NDVI gives us an index where from -1 to 1, where 1 is the highest amount of productivity for the plant life. All right, so how we do this is we're going to open up a module called VegIndex. So up here in our toolbar, we start typing in VegIndex, VegIndex, and we get a lot of options for different vegetation indexes. And there are a lot to use. And for this one, we're just going to select NDVI, and it's going to ask you for the red band and the infrared band. So we're going to pick 2020-213 band 4, and then for the infrared band, go to your project, pick band 8, making sure that the two dates are the same. And you're going to use this for both sets of dates. You're going to end up in this part of the project with two different NDVI images. So for your output image, you need to type in NDVI by 2020-02-13, and we click OK, and it runs, and after a couple of seconds we should get an image here. So this image is something that is actually quite useful, because we can look at it and we can check out how much biomass or how much primary productivity is going on here. And so the legend here goes from a minimum of -0.78 to a maximum of 0.99. So the highest amount of productivity that you can do is a 1, and the lowest would be a -1. So the closer it is to 1, that means the vegetation is healthier, that we have a lot of photosynthesis going on. So we can explore this image a little bit. You can zoom in and we'll see that, yes, the clouds are in here. Now, what does this mean? The clouds are not plants. So what does that mean? Well, this means that there still is near infrared being reflected, and there still is red being reflected. But because we're getting below zero, then we're not really interested in in that. And we know that these are clouds, and we're going to have to deal with those clouds later. And we know that these are clouds because we have already looked at the true color image and the false color composite. Out here we have the ocean, and there is photosynthesis that happens in the ocean because there are plankton and diatoms creating oxygen and all kinds of plant life in the sea. But we're not going to be worrying about that for this project. We are interested in land cover. So if we zoom in a little bit here, we'll see this area, and we can see some settled areas, some settlements, some villages, and we see that evidence because we have lower NDVI readings where there are housing, for example, versus where there is just forests and gardens. The values are going to be higher. And if we go up here to around the summit of the volcano, in our false color image, we saw that area as being much darker than the surrounding red areas. And here in our NDVI, we see that there's more vegetation the farther away you get from that summit. And as we get closer up here to the volcano, we see that the NDVI values are very low. And we're also aware that we do have some cloud cover nearby, and so that might throw a little bit of interference into any particular analysis that you would do. And we're going to have to take into account the clouds, and we have to mask out those clouds, and we're going to mask out the ocean also later on. So you want to make an NDVI image for February 13th, and you don't have to close this. You want to also make one for May 28th. So we are going to switch those images, the B4, band 4 for May 28th, and making sure that you're always checking the right folder and the right file name. May 28th, band 8 for the infrared, and you always have to keep on your toes here. Right? I'll change the file name, update that file name to 2020-528. So now we have two NDVI images, one for before and after, and you're going to submit these two images as part of your assignment. So one thing that we have to do next is we have to compare. We have to see, is there a difference here? Is there any change in these two images? So for that, just as how when we make an NDVI and that NDVI process, that equation compares the near infrared with the red bands, we have to compare these two images. And so we want to find out if anything has changed from February 13th to May 28th. So the way that we do that is by opening up the image calculator. So there's an icon here on your screen. You're going to click image calculator. We want to find out if there is any difference in each individual cell from one cell to the next. Did this change from February to May? There's that cyclone, that hurricane that hit in April. And so if there was a lot of damage, we want to be able to find out, is that area still damaged or has it regrown? And so we can use an image calculator to find that out. So we're going to type in diff for difference. Sorry, let's do May 20 minus Feb 20 because that corresponds with the formula that we're going to use. And so we're going to go to this box here for expression to process. You're going to find in your working folder your NDVI for May 28th. You want to put that one first, and you click subtract, you click insert image, and you select NDVI for February 13th. And we have to do that in this particular order because this is a math equation. We want to find out, is there a change before and after? And so May is the second. May is the after. So we want to find out, is there an increase or a decrease? So in order to do this correctly, it has to correspond with, our correct use of just that basic math subtraction formula. So you've got to put May 28th first and the February image second, because we want to see, was there an increase or was there a decrease or was there no change at all from pixel to pixel? Once you've got that formula typed in, you click process expression, and it's going to compare every single pixel in that image with the other file. All right, so this is our output here, and the first thing you'll notice is that we've got this giant splotch of red here in the bottom. And so the first thing that we should kind of just mentally take note of is that we have a lot of differences in clouds here. So if you've got a lot of cloud cover in the February image and not so much cloud cover in the May image. And so that you will see that this makes a big difference in our difference image. That the reason that this is red is because we have some changes here to our NDVI values. All right, so how do we read, how do we understand the output here? The negative 1.25 to positive 1.0, that's no longer really in that NDVI index of measuring photosynthesis or health. All those numbers mean at this point in this image is, was there an increase or decrease? Like how much did each pixel change from February into May? And so when you see these red clouds here, that means that there was a drastic increase in NDVI values from February to May, but we can easily do a visual check and we say, well, that's because there were clouds here in February blocking all of the vegetation, and then in May, most of those clouds were gone, and so we see all of that greenery, all of that vegetation that's growing. And so the software thinks that this is just a massive increase in vegetation. The area that we are more interested in is the populated areas, which are the coasts along here, and that's the coast that's along here, and that is mostly this kind of yellow color in my image here. All right. Well, the next thing that we're going to have to figure out is are there any changes that happened here, and are those changes, are they significant changes? Because of course there's going to be just regular variation in how the plants grow, and plants living and dying. You know, there's going to be that regular vegetation change that sort of is both seasonal and, you know, is it just kind of a random variation? We want to know, was it really a big deal? And so for that, we actually have to run some statistics and find out the average value, and we've got to establish some thresholds to find out was there really any significant changes that we should be concerned about. So that's coming up in the next video.